Welcome to the Explainer. Today, we're cracking open the playbook that separates the pros from the amateurs in the world of Python. We're going to go way beyond the basics to uncover what the seasoned developers really know. So, what's the secret sauce? What's the real difference between a developer who's just good with Python and one who's truly great? You know? It's a great question, and the answer, well, it's probably not what you're thinking. It's definitely not about memorizing more of the standard library. See, the real jump from good to great, it happens when you stop chasing more syntax and you start facing the cold, hard truths of the language itself. Knowing Python's limits is every bit as crucial as knowing its strengths. All right, let's get right into it. Section 1, Python's brutal truths. These are the core realities you absolutely have to internalize if you want to write effective, professional-grade Python code. First up, let's talk about the big one, the thing that trips everyone up, the Global Interpreter Lock, or the GIL. Look at this slide. It's all about two different kinds of work. If your code is doing heavy math, that's a CPU-bound task, the GIL makes multithreading pretty much useless. Seriously, only one thread gets to actually run Python code at a time. But, and this is the key, if your code is just waiting for something, like a network response or a file to load, that's I/O-bound. The GIL kindly steps aside and threading works perfectly fine. The pro move? Use multiprocessing for the heavy lifting. Okay, brutal truth number 2. Python is slow. And you know what? That's totally okay. Pros don't use pure Python for the really intense number crunching. They use it as glue. They write simple Python code to connect and control super fast libraries like NumPy or Pandas, which are actually written in C. Python's real speed isn't in how fast the code runs, it's in how fast you can write it. Okay, so we've faced the hard truths. Now let's talk solutions. This section is all about the patterns that pros use to write code that's not just clever, but also super memory efficient and ready to scale. If you take one thing away from this section, let it be this. Stop using list for everything. I'm serious. It sounds so simple, but making that mental shift away from the default data structure is an absolute game changer for your code's performance and memory footprint. And this chart right here shows you exactly why. It's so clear. A list, it just shoves everything into memory all at once. You want to process a 10 GB file? Well, you better have 10 gigs of RAM ready to go. A generator, though, it's a completely different beast. It works one item at a time. It just says, here's one piece, let me know when you're ready for the next one. It barely uses any memory at all. And here's where it gets really powerful. You can actually chain these generators together into what's called a pipeline. Each step you see here, reading a line, cleaning it, pulling out the data, each one is its own little generator, passing the data along to the next one without ever loading the whole data set. This is how you process massive files without crashing your system. Okay, writing cool, efficient code is great, but it's only half the battle, right? Getting that code out into the real world, into production, that's a whole other challenge. So in this next part, we're going to talk tools and strategies, because mastering the ecosystem is absolutely non-negotiable. Man, the tooling world has changed so fast. The old way meant juggling a bunch of separate tools. Pip for packages, Flakegate for linting, Black for formatting. The modern standard? So much better. We've got these new tools like Rough and UV, and they're written in Rust. They are blazing fast. We're talking 10 to 100 times faster. And the best part? They replace all those other tools. This is the new way to do things, for sure. All right, here's a hot take on production that might surprise you. For years, everybody said, use Alpine Linux for your Docker containers. They're so small. But for Python, well, that's a huge mistake that'll give you a massive headache. So why not Alpine? What's the deal? It all comes down to something called the C library. See, most Python packages you download are already pre-compiled into things called wheels, and they're built to work with the standard C library, glibc. That's what distributions like Debian use. Alpine, on the other hand, uses a different one called Musel. Because of that mismatch, you have to recompile everything from scratch during your build. It's slow, it's buggy, and ironically, it can actually make your final image bigger. Just don't do it. Debian Slim is the way to go. All right, last section. We've talked code, we've talked tools. Now let's talk about the thing that really ties it all together, the mindset. This is about that high-level architectural thinking that truly defines a senior engineer. Okay, listen up, because this one is a silent killer for any app that uses a database. It's called the N+1 problem, and it is so easy to accidentally write code that does this. So let's say you fetch 100 users from your database. Okay, that's one query. But then, in your code, you loop over those users and, one by one, go back to the database to get each person's profile. That's another 100 queries. 1 plus 100, you've just made 101 trips to your database. That is an absolute performance disaster. It will just crush your app.
So how do you fix it? You have to be proactive. You tell your ORM, the thing connecting your code to your database, to grab all the data you need upfront. For one-to-one relationships, you use select related function, which does a smart SQL join. For many-to-many, you use prefetch related function, which does it in a second efficient query. Either way, you're cutting down hundreds of queries to just one or two. It's a lifesaver.
This is another hallmark of a senior dev. They don't just have one hammer for every concurrency nail. They look at the specific job. Are you just waiting on network calls all day? Threading is your friend. Are you crunching numbers and doing heavy math? Multiprocessing is the way to go to get around that Jill. Do you need to handle thousands of connections at once, like a chat server? That's a job for async I/O. Choosing the right tool is everything. Okay, one last landmine to watch out for, the pickle module. It seems super convenient for saving and loading Python objects, but it is incredibly dangerous. The process of loading pickled data, unpickling, can let an attacker run any code they want on your machine. So the rule is dead simple. If you don't 100% trust the source of the data, do not unpickle it, ever. Just use JSON or another safe format instead. And all of this really leads us to the final and maybe the most important truth about why Python is so dominant today. It all comes down to this one simple idea. Ultimately, when you put it all together, you realize Python's killer feature isn't raw execution speed, it's development velocity. It's a language built to help people and teams bring ideas to life faster than almost anything else out there. It's the ultimate orchestrator, the ultimate glue. And that leaves us with a final question, right? In a world where time to market is everything, isn't that the most important kind of speed there is?